Hi guys, this is Danielle Gillham. I am here to show you about Module 3, Chapter 4. Chapter 4 is number theory, and Chapter 5, integers. First, I'm going to be showing you about divisibility test on how to decide which numbers 2 through 11 can be a divisor of the numbers below. We'll be teaching you about 2 through 11 divisor rules. Or divisibility rules, sorry. Okay, so here's a graph. And we know. So, 2. Let's start with 2. 2 is divisible by a number if they say if the last number is divisible by 2. Basically, you can just tell by whether it being odd or even. So 4 is even, 4 is even, or 1 is not, 0 is an even number, again, and 8 is even. Now 4. If the last 2 digits is divisible by 4, then the whole number is divisible by 4. So 84 divided by 4 is 21 even. So yes, 684 is divided by or divisible by 4. 64 divided by 4 is 16. So yes. 51 divided by 4 is 12.75. So there's a remainder of 0.75, so no. 90 divided by 4 is 22.5, so no. 40 divided by 4 is 10, so yes. And 28 divided by 4 is 7 even, so yes. Let's go on to 8. If the last 3 digits, so 684, the whole number, basically, the last 3 digits is divisible by 8, then the whole number is divisible by 8. So 684 divided by 8 is 85.5. So no. 64 divided by 8 is 8. So yes. 51 divided by 8 is 6.38. So no. 490 divided by 8 is 61.25. So no. 740 divided by 8 is 92.5. So no. And then 528 divided by 8 is 66. So yes. Let's go to 5. So if the last number or the last digit, let's get an eraser. Hold on one second. So if the last digit is say a 0 or a 5, then yes. But if it's any other number, then no. So we have no, because the last digit is a 4, last digit is a 1. We have a 0, so yes. Another 0, so yes. And then no. Now 10. We're going to skip to 10. Only if the last digit is a 0 can it be. So these two are, and these are not. All right, let's go on to some others. The divisibility of 3. So if the sum of all the digits is divisible by 3, and the whole number is divisible by 3. So for 684, for instance, we'll do 6 plus 8 plus 4 equals that equals 18. And 18 divided by 3, oh gosh, sorry, equals 6. Again, guys, sorry about the handwriting. So yeah, it's an even number. There's no decimal or remainders. Let me clear this one out. I'm gonna show you one more, and then I'm gonna fill them in. 2064. So we're gonna do 2 plus 6 plus 4 equals 12. Okay, so 12 divided by 3 is 4, no remainder. So 2064 is divided by 3. All right, I'm going to do the next one because it also ends up being 12. 5 plus 1 plus 5 plus 1. And again, 12 divided by 3 is 4, so yes. So 644 and 49, or 490, sorry. So if you add up all those digits, you're going to get 27, and 27 divided by 3 is 9. So yes, if you add up these digits, and you're going to get 32, and 32 divided by 3 is 10.66. So no. If you add up all these numbers, you're going to get a total of 27, and 27 divided by 3 is 9. So yes. Let me erase these. Okay. Let's do 6. If the number is divisible by 2 and 3, then the whole number is divisible by 6. So 684 was divisible by 2 and 3. So yes for the 6. Again, with this number, yes. Now 51,051 was not divisible by 2. So no. These both were divisible by 2 and 3. Or this number was divisible by both 2 and 3. This one was not divisible by 3. So no. And this last number is divisible by both 2 and 3, so yes. 7. 7's kind of sounds tricky. You're going to take the last digit, 4, and you're going to double it. And then after you've doubled it and subtracted, hold on. Oh, hold on. I did that wrong. Excuse me. Okay. So you're going to take 4. So you take 4 and multiply it by 2 because you're doubling it. So you're going to get 8. You're going to take the remaining of the number 68, and do 68 minus 8 equals 60, and 60 divided by the number 7, because the 7 divisibility rule, equals a total of 8.57. So no, this number is not divisible by 7. Let me erase this. I'm going to show you one that is. I'm going to tell you right now, this one's not divisible. So this number, 5, or 51,051. So 1 times 2 is 2. So we have the 2. And then you have the remaining number, 5,105. Minus 2 equals 51,003. And so that's not broke down enough, so we're going to take the 3 and double it. So now we have 6. So now we have 510, the remaining, minus 6 equals 504. And let's break it down some more. So now we have 504. And we're going to take the 4 and double it. And it is now 8. 50 minus 8 is 42. And 42 divided by 7, we know off the top of our head, is an even 6. So since we got an even number without a remainder, that means yes. So I'm going to plug these in for y'all. This one will end up as yes. No. And no. Okay. Now we're going to do 9s. 9. If the sum of the digits is divisible by 9. So, 6 plus 8 plus 4 equals 18. Is 18 divided by 9 even? Equals 2. So yeah. Let's try another one. 2 plus 6 plus 4 equals 12. And is 12 divided by 9 even? No, you're going to have a remainder. So, no. And so this one isn't either. This one is, right? This one's not, and this one is. Okay. Now we have 11. 11, you're going to subtract the last digit from the number. So 684. So it's So subtract the last digit from the number formed by the remaining digits. If the new number is divisible by 11, the original number is divisible by 11. So we're going to do this number. So it's minus 8 plus 4 equals 2. And no, 2 is not divisible by 11. So let's try another one. Let's try this one. 51,051. 5 minus 1 plus 0 minus 5 plus 1. So you're just alternating, and your answer is going to be 0. So look for this. So this one is a no, this one is a yes, 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 and no. All right, enough of that problem. Let's try another one. I was just showing you a few of the 3s, the 6s, the 9s. Okay, now we're going to demonstrate I'm going to demonstrate the use of the process of 9s to check your work. So right here we have 416 plus 7,490 plus 69,844 equals 112 and 790. We're not sure if this is correct. We're trying to figure out if it is. So how we do this is you have 416, 700, 490, 69,844. This is probably hard to tell. Here. Here, we'll get it all arranged for you. All right. So this is supposed to equal this number. Let's find out. So what you're going to do for the process of 9s is you're going to go through and add each number within that line. So we're going to do 4 plus 1 plus 6 is 11. And then these numbers together are 20. And then these numbers together are 31. And then if I were to add up the number that it's supposed to be, and then we don't have to worry with the 0, you're going to get 20. And you don't want 2-digit numbers, you want just 1-digit numbers. So we're going to go through and we're going to add them up again. So 1 plus 1 equals 2. 2 plus 0 equals 2. 3 plus 1 equals 4. And 2 plus 0 equals 2. So now we have 2 plus 2 plus 4 equals 8. And 2 and 8 does not match up. So we're going to say, no, this was not correct. The actual number to these is 77,750. You can always go back through and check yourself. I'm not going to do that this time since I'm living on time. We're going to go to the next one and try another one. All right, let me get these plugged in. Okay. So this is what it says it's supposed to be. Let's check it out. 8 plus 5 plus 5 equals 18. 6 plus 8 plus 8 plus 8 equals 22. Again, sorry about the handwriting. 2 plus 5 plus 2 plus 5 is 14. And then we have 17. And then we have down here, all these add up to be 24. Okay? So, if I were to add up these numbers again, you're going to get 1 plus 8 plus 9, 4, 5, 8, and this one's 6. So we're done there with this one. Now we got to add these up, or just these 4. Sorry. So 9 plus 4 plus 5 plus 8. Well, that equals 26. And we got to add these together. Is 8. And so the 8 does not match up with the 6. So the actual number is supposed to be 23,984. So if we wanted to check it just by using this number, 2 plus 3 plus 9 plus 8 plus 4 20 sets. If you were to add the 2 and the sets, you get 8. And this doesn't always work out. You might sometimes have, a number that, say, I have a 9 right here and a 3 right here. Well, that's going to add up to 20 sets and then add up to 8. So you're not always going to have a correct answer, but it can sometimes help a little bit. All right, we're going to go on to some more problems. I had this one broke down more because it's a subtraction. So if you're doing a subtraction one, it's best to turn the problem into addition. So you're going to just set the final product with the lowest number, the bottom number, and see if it's correct. And so afterwards, I found out that 8, 7 doesn't match up, and that the correct answer is actually supposed to be a total of 74,688. So it was 10 points off. If you can just turn this into a addition problem when you have subtraction, it makes it so much easier. All right, so here's a multiplication problem. Okay. So if I were to draw 337 times 620, you're going to go through and you're going to add them up again. So 3 plus 3 plus 7 equals 13. 6 plus 2 equals 8. If I were to add up the digits of 209, 940, I'm going to get a total of 24. And 2 plus 4 is 6. This is your final one. And 1 plus 3 is 4. So instead of adding right here, like we have in the past with the adding, you're going to multiply. So we're going to do 4 times 8 is a total of 32. And then you're going to add 3 plus 2 to get 5. And 6 and 5 don't add up. So, no, they don't match. So, therefore, 337 times 620 most likely isn't 209,940. But it is actually 208,940. It's off 5,000. I wish I could show y'all more. Hate that. Let's go on. So we have these colored rods here. They are 1 centimeter squares. We have 2 centimeter, 3, and all the way up to 10. So we say that a rod measures another rod if a number of the first rods placed end to end are the same length as the given rod. Demonstrate these questions. So show which rods will measure the 9 rod. So I'm just going to talk you through this one. Of course, the 9 rod's going to measure the 9 rod. And then a 3 and a 6 will. 3 of the 2 blocks, 2 of the 3 blocks. If you're just doing your little tree, those would be the 2. And then 9 of the 1 blocks. But of course, you can add, the 4 and the 9, the 4 and the 5 together if you're doing addition. And let's try another one. 6 rod. If you break it down in a factor tree, you have 1 and 6 on the top. So of course the 6 will work, 6 of the 1s will work, 2 and 3 go together. So 3 of the 2s and 2 of the 3s. We're going to use those parts to show the greatest common divisor of 9 and 6. So, nine broke down like so. So the greatest common divisor also means the greatest common factor. So the shared factors are 1 and 3. So out of 1 and 3, 3 is the greatest common factor or greatest common divisor. That's how you do that one. All right. How many revolutions will the small gear make before A and B on the teeth are at the same position? So, oops, sorry. So we have 84 and we have 48. And 48 broke down once you do a tree. You're going to have if you multiply 48 by 3, you get 144. And if you keep going on, then like so. So I'm going to skip to 7. 48 times 7 is 336. If I do 336 divided by 84, then I get 4. So it is going to take 84, the gear with 84 teeth, 4 times around, and the 48 teeth 7 times around in order for them, or 4 times the amount as 7 times the amount, in order for them to meet in the same position again. Let's try another one. Okay, back to the blocks. If I replace a 10 rod and an 8 rod, you will get a 18 rod grain. So what will measure 18? If you do a factor tree for 18, you're going to have 2 9s, a 1 block of 18, and then you're going to have 18 of the 1s. You'll have 9 of the 2 blocks, 6 of the 3 blocks, 3 of the 6 blocks. So that's how you figure that out. You just want to pay attention to your factor trees. Show all the lengths of all rods or trains, which can measure the 18 train. That's what we just did. So you'll use these, like I said, you'll use these rods to demonstrate how to get do the factor tree, and then you can use it to find greatest common divisor. So here we have at least common multiple chart. Okay, so we have the numbers 48, 25, and 65. So we're going to plug in. I have an extra box, so we're just going to ignore it. Hope y'all can read that. So we're going to start with 2. We're going to break them down in half. And you're going to get 24, 25, and 65. Because 65 does not break down in 2 and 25 does not break down with 2, so we're going to leave them as is. Let's do 3. 24 divided by 3 is 8. 25 cannot be divided by 3, so it's 25 again and 65 again. 65 divided by 3 is unit, so it won't work. Let's do 5 so we can break down the 25 and 65. This one's going to be 8 again because it can't be broke down. 25 divided by 5 is 5. 65 divided by 5 is 13. Okay. Can't break these down anymore, so we're just going to break down the 8. So we're going to use 4. That's going to break that down to 2. And bring up 5 and 13 again. So those were those steps. So then you'll have 2 times 3 times 5 times 4. Times 2 times 5 times 13. You're going to get 15,600. So the least common multiple of 48, 25, and 65 is 15,600. That's a lot. So that's an easy way to break it down without having to try to play the little guessing game. Let's try one more. So we have 40, 12, 44, and 363. So 40, 12, 44, and 363. So we're going to start with 3. 40 cannot be divided by 3 evenly. Keeping it, this can be broken down to 4. This cannot be broke down, so we're going to keep 44. This can be broke down to 121. Now let's do 4. This can be broke down to 10. 1. 4 goes into 44 11 times. 4 goes into 121 times. Because it doesn't go at all, so we're just keeping the 121. Let's try 11. Keeping it, broke down to 1, and 121 divided by 11 is 11. Okay, now let's try 2. This goes down to 5, keeping 1, and we have to keep 11. So we have 3 times 4 times 5, or 11, times 2 times 5 times 1 times 1 times 11. And you're going to get 14,520. I really like those. Those are very useful. Back to the gears, this shows you the breakdown ratio of 84 to 48. Smallest ratio will be 7 to 4. We did that one. All right, magic square. So, I've heard from people that you use the little guessing game of just plugging in numbers. But for the way this was set up, well, usually if you have one like this, but I just it was set up to where you just had to flip it over to its side. So, Let me pull up my stuff. Try to get to let me draw. There we go. So, starting with the 0, because we have a number line of -7 to 1, I think. Yeah. So we have all the numbers from there. So usually we start with 1 and work your way back, or -7 and work your way up. So since we already had the 1, you would move down 1 and right 1 and put the 0, and it's already there. And then you'll do the same. So move down 1 and right 1, and this will be -1. Down 1 and right 1. And since this one is taken, you're going to put it above it instead. And then you're going to move from there. So down 1 and right 1, -3, down 1 and right 1, -4, down 1 and right 1. There's 1 there, so we have to move above the -4, put -5, and then down 1 and right 1, -6, and down 1 and right 1, -7. And so that's how you'll do that. That makes it a lot simpler. And there's the final product right there. And then you'll double check yourself and see if they add up to be the same amount, and they all equal -9, whichever way you go. All right, guys, thank you so much for learning with me on my presentation for Module 3, Chapter 4, Number Theory, and Chapter 5, Integers. Thank you.